Hello, this is a short video to show you the proper way to do uh, chemistry problems where you need to convert moles to grams or grams to moles using mole to mole ratios or gram to mole ratios when they're asking you, how many moles of this reactant or this product can be produced if you have this much reactant. So anyway, the best way to do these are to use the factor label method, because if you use the factor label, and sometimes we can also call this dimensional analysis. There's a document in the resource documents folder of the course of the modules that goes over how to use this method, but I'm going to show you how to use the method with this short video. Okay, so it says how many moles of ammonia are produced if you have 4.2 moles of hydrogen and we react those with an excess of nitrogen. So our limiting reactant is going to be the 4.2 moles of hydrogen, right? And that's what we're given. So we always start out by writing down, okay, what are we're given 4.2 moles of hydrogen, okay? So that's what we're going to start out with. And whatever we start out with, we always write that over 1, and we always carry through whatever units. So we have 4.2 moles of hydrogen, and notice it's H2, so we need to make sure. We have 4.2 moles of hydrogen over 1, because that's what we're given. We're going to start out with that. And so it's asking how many moles of ammonia. So we're interested in this reactant and this product is what is involved in this question. And so we know that we're going to multiply by a factor that has moles of hydrogen down here, right? And we're trying to get to moles of ammonia. So we need a ratio of moles of ammonia to moles of hydrogen. So it looks like we have 2 moles of ammonia to 3 moles of hydrogen. So we're going to put 3 here, and we're going to put 2 moles of ammonia up here. Now, how do we know? And what's good about this is because you can check that you set it up correctly. Because if you set it up correctly, all of the units are going to cancel except for the units for what you're solving for. And so we're solving for moles of ammonia, and it looks like right here, this should be 2 moles, right, of NH3. So we have 2 moles of NH3, 3 moles of hydrogen. And so we know that the moles of hydrogen canceled, and we're left with moles of NH3. And so we just now multiply that through. 4.2 times 2, right, is 8.4 moles of NH3 divided by 3. And so you just do the math. 8.4 divided by 3, and see if I can find that. Okay, 8.4 divided by 3 equals, and that's equal to 2.8 moles of NH3. Okay. And so you see why it's called the factor label method, because if we use our labels, we can make sure that we factor it out so that we're setting it up in a way that we end up with, what we're looking for. All right, let's try another one. So here it says tin metal reacts with hydrogen fluoride to produce tin 2 fluoride and hydrogen gas according to the following balanced equation. And so the balanced equation is up here. So let's look at, okay, so here's the question. I forgot to put the question on here. So here's the question, or the problem. How many moles of hydrogen fluoride are required to react completely with 75 grams of tin? So the first thing we want to do is to figure out, okay, what are we interested in this equation up here? So we're interested in, it's asking how many moles of hydrogen fluoride. So let's find hydrogen fluoride. So here's hydrogen fluoride. How many moles of hydrogen fluoride are required to react completely with 75 grams of tin? So here is 10, okay? So we're going to need the moles, we need the molar mass of tin is 118.69 grams per mole. We'll need that, we know. So let's look at this. So what are they giving you now? So we know which two formulas or which two compounds we're interested in. So we got those. Now, what are they giving you? They're giving you 75 grams of tin, right? So that's what we're going to start with. So we have 75 grams of tin, or we're going to write SN, right? 75 grams of tin. So what are we looking for? Moles of hydrogen fluoride. How many moles of hydrogen fluoride? So we're looking for moles of hydrogen fluoride. This is what we're trying to get to here, right? So we're going to take, and this is what we're given, right? So we're going to take 75 grams of tin and somehow figure out, using what we know from that equation, how do we get to moles of hydrogen fluoride that are needed. So let's do our first step, which is to write down what we're given over 1. 75 grams of tin over 1, okay? So somehow we have to get to moles, right? Because we have to compare the mole to mole ratio up here. We can't get from grams of tin to moles of hydrogen fluoride without going to moles of tin first. So we need to use the molar mass factor for tin. So we're going to multiply times 118.69 grams per mole. And we want moles on top. So we're going to do 1 mole, right, of tin is equal to 118.69 grams of tin, right? And now, look, we can cancel out grams of tin. And we're left with moles of tin. Now you can start the next problem down here, like down below, or you can just keep going with this. So let's do, now we need to get to moles of hydrogen fluoride, right? So now you need to use our mole to mole ratio. So we have 1 mole of tin to 2 moles of hydrogen fluoride. And we want, our answer needs to be in moles of hydrogen fluoride. So let's do moles of hydrogen fluoride up here. Sorry, moles. Let me erase that real quick. Yeah. So moles of hydrogen fluoride should be up here, and down here is going to be moles of tin. And we said we have 1 mole of tin to 2 moles of hydrogen fluoride, right? Now we cancel out moles of tin, and we're left with moles of hydrogen fluoride. And so now all we have to do is multiply through 75 times 1 times 2, and then divide by 118.69. Okay? What if we needed to, what if they wanted to know how many grams of hydrogen fluoride? What if they wanted to know how many grams? Well, we just add another step here, right? We would say, okay, so what's the molar mass of hydrogen fluoride? And I'm not sure about that. I would have to look it up. Let's see. The way we would set it up, though, we would multiply. Now we want grams of hydrogen fluoride here and moles of hydrogen fluoride here. So 1 mole is equal to, whatever this is, X grams. And then you would multiply one more time. You would multiply, this times X. And because we could cancel out the moles of hydrogen fluoride. So using the factor label method is really important in this part of the course where we have lots of math, where we're looking at the different moles to mass, mole to mass ratios, mole to mole ratios. So I would encourage you to kind of do your work in this way, and then it's very easy to check that you've set it up correctly. Okay? All right. Hope that helped.